All right, so I actually just recorded this without sound, so I'm just going to be talking over the video I've already made, so if it looks a little weird, that's why. But we are starting a new unit, and it's going to be on sequences and series. So I just went ahead and pulled up the formula sheet that you're going to get on your final. So I looked up North Carolina pre-calculus final exam like formula sheet or something like that, and it's used for AFM, discrete, and pre-calc. So you haven't really used it a lot yet because it only has a lot of sines and cosines and a little bit of conics, but I pulled it up specifically because it has a ton of formulas right there on sequences and series, which is great. So you don't have to memorize any of these that I'm going to be giving you right here. You're just going to be given them. You just got to make sure you know how to use them and what the different letters mean. So it should work out really well for you. So moving on in just a second. All right, so we are going to be starting with sequences and series, and the first kind is arithmetic. So arithmetic sequences is when you are adding or subtracting each time to go from each number to the next. So you could be adding 5 each time, you could be adding a fraction, or you could be subtracting a number, same as adding a negative, whatever. All right. The next vocab word for arithmetic is common difference. And lucky for you, we use a D to stand for it in all the formulas, which makes it really easy to remember. So the common difference is a number that you are adding or subtracting every time to get from term to term. So there's your vocab to start. Next is our formulas. So the first kind of formula that we're going to use is recursive formula, which isn't super useful to find terms later on in a sequence, but it's really nice just to get from term to term. So it's a sub n equals a sub n minus 1 plus d. So the d stands for difference, obviously, and the a sub n minus 1 is your previous term, and a sub n is the next term. So for example, if you have that term and you want to get to the next one, you just add d and you get to the next term. So that's all recursive says. This is how you get from one term to the next. So that's why it's not super useful for what we're doing. The one you're more interested in is the explicit formula, and that's going to be one that you are given, which is very nice for you. So it's a sub n equals a sub 1 plus n minus 1 times d. So let's just go ahead and label each piece. A sub 1 is the first term in your sequence. N is the term the number term that you want to find. So let's say you want the 5th term. You would put a 5 right there. D is obviously difference, and then a sub n is the term, like it will give you the term that you want. So maybe I should change, n to the number term you want. And it will just spit out any term you want to find, which is super helpful. All right. Next will be, I don't know what I was talking about. I'll fast forward in my video just a little bit. All right, next is geometric. So go ahead and write down geometric, and that is when you multiply each time. So I feel like you might be saying something like, what about dividing? Well, you could be multiplying by a fraction, which would be the same thing as dividing. So geometric is multiplying every time. So your common ratio is what you have instead of a common difference. I'm going to use R, and this is the number you're multiplying each time to get from term to term. And like I said a second ago, it could be a fraction. So you could be multiplying by 1/2 every time, and that would be geometric. So hopefully I'm going to delete that because I don't need it yet. Yep, that's what I'm trying to do. All right, so our formulas are going to be the recursive again, and like I said, that one's not super useful, but there's the recursive. A sub n equals a sub n minus 1 times r. So it will get you from term to term, multiplying by the common ratio. Now here's the explicit, the much more useful formula in my opinion, and that's going to be a sub n equals a sub 1, which is your first term again, times r to the n minus 1. And that's your explicit, and it will give you any of the terms that you want. So let's say you want the fifth term, you plug in 5 right there as an example. All right, here's the new stuff. So everything up until now was review from Math 1 a little bit. Now we're getting into the stuff that's more useful for us and then for calculus. So sequence is the first thing we did, and it's just an ordered list of numbers, pretty basic. But the other part is series. So a series is the sum of a sequence. So it's when you actually add up all the terms. So try not to mix them up. So sequence is just ordered list. Series is a sum of a sequence when you go ahead and add all of them up. So here's the picture that I had in there earlier. I need to add into there. So this is something you've probably seen on my wall. And now you hopefully are going to know what each of the things are. So that big E is a sigma. And it stands for sum. And we're going to be using it to represent sum going forward. So that big E means sum. You should know that. And it's summation notation. And it's a letter. It's the Greek letter sigma. And I'm just going to go ahead and label all the parts that you'll see on it. So you'll see a number at the bottom. And it'll be K equals 1 most likely. It could equal anything. And then the number at the top. And some formula on the inside. So here's what all of the different parts are for. So that number at the bottom tells you the first number that you want plugged in to your sequence. It's also called the index of the summation. K is your index. And then the number at the top tells you the last number that you want to plug in. So let's say that you want to plug in the first 5 numbers into a sequence and add them up. So your K would be 1, and then your N would be 5. So you'd be plugging in 1, 2, 3, 4, 5, and so on. All right, so let's try an example, just because this is a little bit newer than some of the other stuff we were doing. So I would write out, this is a series, for example, and look, they're being added together, so that's how you know. And the directions, for example, would say, put in sigma notation, put in summation notation, however you want to word that. So I would start by trying to figure out what the heck is going on. That's my first term. And then my next term is -1, and then 5, and then 11. So I need to know if this is arithmetic or geometric, first of all. So I'm going to start by finding out, so I'm adding 6 every time. So it definitely is arithmetic, so I'm going to want to use the arithmetic formulas for this. So I can just go back up and check, and the arithmetic formula is right there. A sub n equals a sub 1 plus n minus 1 times d. So that's the one I'm going to use. So I'm going to draw my sigma, and I'm going to put in my first term plus, and I'm going to use k just because a lot of times they use k with sigma. So I'm going to do k minus 1 times 6 because that's my common difference. And just keep going. So I'm going to put a 1 there because if you plug a 1 in for k, you get 1 minus 1, which is 0, which gives you -7. So that works for my first term. So my next step is just to simplify this formula. So I distributed the 6 to each term, and I still have that -7. Keep simplifying, you get 6k minus 13. And I'm also going to put parentheses around it. Hopefully in a second. Yep, there we go. That's just so that you know that the sigma applies to the whole formula, not just the 6k. Now I just need to figure out what goes on the top. I got to figure out what that term is. Is it the 5th term, 12th term? I don't know. So I'm going to take my formula and set it equal to 53 and just solve. So I'm going to add 13 and divide by 6. And that tells me that k is 11. So that means that was my 11th term. So I put an 11 on top, and I circle it and give myself a pat on the back because I just turned that into sigma. It's the same thing, just written in sigma notation. All right, last little bit that we have to do is the sum formulas that you are actually given at the top for arithmetic and geometric. So we're going to do sum of arithmetic first. So that's one of the formulas you're given right there. To the left, it's S sub n equals n over 2 times A sub 1 plus A sub n. So I just wrote it down right there. So that's the sum for an arithmetic. And I think it's pretty self-explanatory. N is how many terms you have. So let's say that you had 6 terms or something like that. Then you would put 6 there, and that'd be your first term, and A sub n would be your 6th term, and that formula would work every time. So let's go to the formula for geometric. I'm just going to speed myself up a little bit. So I've got the geometric formula I pulled from the top looks like this, and it is A sub 1, so your first term, times 1 minus r to the n over 1 minus r. And notice it says for when r is not 1, because that would give you dividing by 0, so we don't want to do that. All right, so we've used both those formulas, but then we look back at the top, and we're kind of confused, because look, there's another sum formula under geometric. What the heck is that for? It doesn't have an n. What does that even mean? Well, here's what it means. It means that that would be an infinite sum. These ones stop. You want like the first 5 terms or whatever, because they have n's in them. They tell you how many terms. These are finite. So you would use these. But we have a formula for when it's infinite, which is super exciting. So our infinite geometric has a different formula. So we can have an infinite series going on forever and ever. Man, I'm writing way too slow. So there's the formula. S equals the first term divided by 1 minus r. And there's one little catch to this though. In order for this to work, we need the absolute value of r to be less than 1. So basically we need it to be a fraction. Because if it's a fraction, that means that your numbers are getting smaller and smaller every time. They're being divided in half or divided by 4, which means eventually they're going to shrink down to almost 0. So you'll be able to add all of them up. If your r is greater than 1, then this formula doesn't work. So if it's greater than or equal to 1, I can't use that formula. But if it's less than 1, like I said, what that's called when it shrinks down is it's converging, and you can use that formula. If it doesn't go down to almost 0, then it diverges, which means you can't find the sum. There you go. Which means you can't find the sum. So pretty easy to decide if you can use it. You just need your absolute value of r to be less than 1, or to be a fraction less than 1 essentially. All right, so from now on you should know which formula to use. The bottom one is for when it's infinite. That one is for infinite. All right, let's just try a couple examples. So here's an example. If you had, that means infinite sum, because there's an infinity on top, starting at 1, and they used n. You don't have to use k, by the way, they used n. And it's pi over 2 to the n, and it's definitely geometric because it's something to a power. But pi is 3.14 over 2, which is greater than 1, which is a problem. It means it's going to diverge, it's going to go off forever, it's going to keep getting bigger, and I'm never going to be able to add it together. So that one I would not be able to find the sum for. This one, let's try. So n equals 0. I could start at 0 to infinity. That's fine. And it's going to be negative 4 over 5 to the n. So the absolute value of negative 4 over 5 is 4 over 5, and that's less than 1, so I'm good to go. So that is going to converge down to something very small, so I can add them together. So I'm going to use the formula. The formula says that you do the first term. So for this one, the first term is you plug in 0. Then you do 1 minus the rate, which is negative 4 over 5. On the top, anything to the 0 power is 1, not 0. Be careful. I feel like someone out there is thinking that it's 0. So I put a 1, and it's 1 plus 4 over 5, which is 9 over 5. And then you flip it, so I get 5 over 9. So the sum of this infinite series right there is 5 over 9. And just remember, that only works if r is less than 1, if the absolute value of r is less than 1. Otherwise, it diverges. All right, so go ahead and rewind this if you need to, watch it again. I'm sure you loved hearing my lovely voice on here. If you have any questions, come and ask me. Other than that, you can start on your Delta Math.